Hello and welcome to Chapter 4. Chapter 4 has 5 modules. We'll be talking about the unequal heating of the earth, air and ocean currents, and then we'll be talking about biomes after that. This initial story is really interesting because it talks about how different plants can only grow in certain regions. And so what that tells us is that the climatic conditions in a given area will determine the plant composition of that ecosystem. Grapes are particularly particular. They cannot handle the freezing temperatures that'll damage the vines. However, they do like the moderately stressful, hot, dry summers, and that makes them gives them the perfect balance of sugars and acids in their in the grapes. So this helps us to see that different regions of the world contain distinct climates, and that affects what can live and grow in each region. Okay, let's go ahead and get started on Module 9. Module 9 has 3 different parts. We're going to talk about the 5 layers of the atmosphere, the unequal heating of the earth, and Earth's tilt and its seasons. So let's start with the layers of the earth. So the layers that are closest to the earth have the greatest mass of air above them, and that causes the layers closest to the earth to be more densely packed and have higher air pressure. These layers are formed by gravity, so as the gravity pulls the air down, it will be more dense as it gets closer to the earth. So I don't know if you knew this, but Olympians really like to travel to Denver before an Olympic Games, probably other athletes as well, and they train at a high altitude because in the that has less air pressure at the higher altitudes, and their body can get accustomed to exercising with less oxygen available to them. Then when they come back down to sea level, they have a plethora of oxygen and their bodies are very capable. All right, here are the layers of the earth. The troposphere is the one that's closest to us, then the stratosphere, mesosphere, thermosphere, and exosphere. So I made a little mnemonic memory device here for you. Trust me in the exam. TR indicates troposphere, ST stratosphere, ME mesosphere, in the thermosphere is the exam exosphere. And the reason that I use this one other than a different one is because in later courses they might divide the thermosphere, this big one, into the exosphere and what's called an ionosphere. And if that happens, then you can just add in, this would be ionosphere, the in here. So if you go on in environmental science, as I hope you do. So thermosphere is, can think of it as Earth's blanket. It's the thickest and hottest layer. It keeps the X-rays and the UV rays from reaching us on Earth. Planes like to fly here in the stratosphere because the troposphere below it is dense with air and water, and that's where Earth's weather is. So this picture of the northern lights is really interesting to me, the aurora borealis. It's amazing to me that just the interaction between solar energy and gas molecules can make up such a beautiful scene. And this is driven by magnetic forces. Okay, some causes of the unequal heating of the earth. There's 3 of them that we'll need to remember. The varying angle of the sun's rays and how they strike the earth. So look at how the sun is striking the earth here, the angle there. If there's less angle, that means that they have to travel less of a distance. So this would be much closer here because it's straight on. Varying surface area over which sun's rays are distributed. So I really liked their example about shining the flashlight onto the basketball so you could see the circle that the flashlight would make, that the light would make on the basketball. But then as you moved the sun or the rays of the flashlight up onto other parts of the basketball, you could see that circle became a longer and longer oval. And so that's what that's talking about, the surface area that the sun is distributed. Albedo is something we'll be talking about a lot in class. It's the amount of incoming sunlight that is reflected off. So this is a great picture for albedo. It shows you that water has about a 10 to 60% albedo, ice 50 to 90%, so it's how much is bouncing back off and being returned. Forests are only 10 to 20%, croplands 10 to 25. Fresh snow is very reflective, has a high albedo, 80 to 95%. So that's going to change the heating of the Earth. Let's go back and talk about tilt now. So the tilt of the Earth, this is what 23.5 degrees looks like. This is a regular 90-degree angle, right angle, and this is a 45-degree right in the middle, so to make it half. And 23.5 is really a pretty small angle. So when you think of this, the Earth, and it's being tilted just a very small amount, don't forget that that is really not a very high amount. All right, so here's a good, when we're talking about the angle and the tilt of the Earth, this is how the seasons are created. So it's important that you understand these four things. So the equinox is when the sun is directly overhead at the equator, and all regions of the Earth will receive 12 hours of daylight and 12 hours of darkness. So this begins begins spring for us in the northern hemisphere and fall in the southern, and vice versa for the September equinox. The solstices, the June solstice is when the sun is directly over the Tropic of Cancer. And we're awfully close to the Tropic of Cancer here in San Diego at 32 degrees northern latitude. So it's fairly accurate for us as well. This would be the longest day of the year, and it's the day that the summer begins in the northern hemisphere, and then vice versa for the December, which would be the shortest day of the year. All right, we will continue to talk about seasons in class, but that is Module 9.